Okay, welcome everybody to the Vancast for Earth Space. Today we're going to just see about these cosmic explosions, the super awesome cosmic explosions like in supernova, which are exploding stars that we've been learning about a little bit. So we'll have to see some video clips first to kind of check those cosmic explosions out again, and then we're supposed to learn about these two massive forces inside atoms, so we'll just review those quickly today, and since we have a way of kind of understanding them. Okay, so first what we're going to do is look at this ptable.com fantastic website. So here we have our elements, we have our atoms, basic elements. And these are all made of star stuff, exploding stars, stars being born, and other stuff. Inside nebula, stars being born inside nebula, which is gas and dust and gravity. So we've been talking about that stuff. And if we look at these little numbers on top here, number 1, there's number 1. We go to helium. There's a little 2 in the top left corner. Those have to do with the parts inside the atom, the protons. In the nucleus are protons and neutrons, and 1 and 1 make 2. So 1 helium and another helium, 2 heliums, if there's enough pressure and heat and temperature, like in a nebula with enough gravity and star stuff, you squeeze them together enough, eventually the insides will touch and you will get helium. And that's what our sun does. And that's what many stars do. There's a huge amount of extra energy produced. Takes a crazy amount of gravity and squeezing to produce, to have one hydrogen and another hydrogen squeezed together so much that they will become a helium atom. So again, these numbers 1, 3, 11, 19, those are all the number of protons and kind of the number of neutrons. It can vary. The neutrons can vary a little bit inside an atom. And squeezing those atoms together is what's giving us the energy for these cosmic explosions. So going back to our note here. Okay, so the two forces that give us this super awesome, crazy amount of energy are the weak nuclear force and the strong nuclear force. Or you can say strong nuclear force, weak nuclear force. It doesn't matter of the order. And those give us the crazy energy that we see in cosmic explosions. Okay, so I'm going to go to some nice examples of cosmic explosions. First one is this scientist, and she's going to look at one type of cosmic explosion.
My phone rings, and my colleague says, "Wake up."
Early on an August morning, at her apartment in Chicago, Marcele Soares Santos gets the call she and dozens of other astrophysicists have been waiting for.
My colleague says, "We received a signal.
They have a nice graphic
we have to
here
take
about
action."
it.
And I'm like, "Oh, this is really happening."
The signal is of vibrations created by a gigantic explosion across the cosmos.
We are talking about 2 neutron stars.
Neutron stars.
130 million light years away, 2 massive neutron stars have violently crashed together.
Very dense objects colliding at approximately the speed of light. The explosion is gigantic, it's tremendous.
Nice graphic.
Astronomers around the globe rush to their...
So that involves those explosions involve the strong force and the weak force of the nucleus. Very, very powerful. And now we'll see another example of a supernova. Exploding star.
But how do you do that? Turns out, there's a kind of star that's perfect for this measurement, a supernova.
Yeah,
right there.
It's right.
Oh yeah,
it might be right there.
A supernova is simply an exploding star. Now, most stars, like our sun, will die a relatively quiet death, but a small minority literally destroy themselves in a titanic explosion at the end of their lives, becoming millions or even several billion times as powerful as our sun.
Because they're so bright, this one object can be seen 10 billion light years away and further.
Okay, so those were nice graphics of cosmic explosions. And we go back here now. So the source of those forces for those crazy awesome superpowers are the nuclear force and strong nuclear force. So I'll have these notes on your assignment describing what we just saw. Okay, and first you have our friend gravity squeezing dust and gases together in nebula. And they squeezes stars so much that the atom gets squeezed on the inside. When the inside parts of atoms actually touch, which is very hard to do, we get cosmic explosions like supernova. And also the energy of our sun is from this squeezing and that's to start it. And then after you get enough squeezing and temperature, you get these weak and strong the nuclear forces in the atom, the strong nuclear force and the weak nuclear force inside the atom give off an unbelievable, super awesome amount of energy. Okay? And the weak force is also used to give the explosive energy of nuclear bombs. And it's also used for nuclear energy and X-ray machines. And the strong force and the weak force are involved with the energy produced from the sun also, and cosmic explosions. Okay, so now you have an idea about the forces involved with cosmic explosions, like supernova and the energy, the light and the heat, and more emitted from stars like our sun. So the forces are gravity, the strong force, and the weak force. Or you can also say the strong nuclear force and the weak nuclear force, they also say. And in the future, we'll be using these forces to create energy, just the same as the sun. They can already use these forces now, but it's at a small scale. But their research is ongoing to be able to manufacture machines that will be able to be used at large scales to produce energy and electricity, and that will happen in our future. So I hope you're smarter now, even though it seems like an odd thing that really doesn't matter. But yeah, it's if somebody ever asks you about stars, your little nephew or niece, you will have a smart answer. Okay, that is all. And I need to turn this off now. I have to learn how to turn the darn thing off. There we go.